Okay, this is video 12F. We're going to do more with the normal model and with StatCrunch, where video 12E left off. So when we're using StatCrunch to solve normal model problems, this is part 2. In the previous video, we solved problems where we knew the boundaries on the horizontal axis, and we were looking for areas, either to the left, to the right, or in between. The questions were all, what's the probability, what's the proportion, what's the fraction? Now, we will know the area breakdown, and we'll be solving for the values that are down on the horizontal axis that led to that area breakdown. So essentially, we're doing the same problems that you looked at in video E, only sort of in reverse. So pause the video if you need to. Go ahead and log on to StatCrunch. Just open it up with a blank worksheet. I'm going to do one more slide before I do that. And if we look at the first example, it says based on the normal model for IQs, they're normally distributed, the mean's 100, standard deviation's 15. Use StatCrunch, draw pictures to answer the following questions. So we'll use StatCrunch in a moment. Question I, give the IQ that marks the 30th percentile for all IQ scores. So before we go to StatCrunch, you need to make sure that you understand what a percentile is. So put in words what the 30th percentile means. 30th percentile, that would tell us that 30% of the people have that IQ or below, and the other then 70% of people are at that IQ or above. So 30th percentile means 30% of people are at this IQ or below. The other 70% are at that IQ or above. And you notice with the percentile, we know the percentage, we know the area. What we don't know is what's at this IQ. What is that IQ? Okay, now we're ready for StatCrunch. So to answer this question, we're going to fire up StatCrunch here. Recall when you open up StatCrunch, where you find that normal model is you go under Stat Calculators, Normal. So it says it right there in your notes, StatCrunch, go to Stat Calculators, Normal. Here it is. This is an IQ problem. IQs have a mean of 100, and a standard deviation of 15. Okay, now before, when we wanted to find the area under the normal curve, we knew the actual IQs. We might have found what's the probability a person has an IQ over 120, so we put 120 in here. This time, we don't know the IQ. We are looking for what's going to show up in this blank right here. What's the IQ? But we do know the percentage. We do know the area under the curve. And remember, the 30th percentile is going to be somewhere down here. 30% of the values are below that, 70% are above. So right in here, in the area part, this is where I'm going to type in 0.30. When you hit compute, make sure your picture sort of matches what you'd like it to look like here. This is the bottom 30%, and we are looking this time for what's the IQ score that goes there. What's that IQ right there? And here it is right in this box. The 30th percentile corresponds to an IQ score of roughly 92.13. So this time the answer is an IQ. We were given the area under the curve. All right. Let's go to part J. Oh, I'm trying to advance the slides. There aren't any slides. Part J. What IQ score separates the top 2% of people from the rest of us? So we're in J now. Top 2%. think about where those folks are. They've got a pretty high IQ. They're the top 2%. So I want this area way up in this right tail to be 0.02. So in this box right here that contains areas, I'm going to type in 0.02. Now be careful. If I just hit compute, look at that picture. That's not what I wanted. That's the bottom 2%, right? I wanted the top 2%. We want to know the people that have this IQ or higher, greater than. So I did need to come over here to the drop-down box and make that a greater than. So make sure your picture, whoops, and it changed my percentage, 0.02. Make sure your picture agrees with what you're trying to find. StatCrunch is great, but it doesn't do all the thinking for you, so make sure that your answer makes sense here. So this says that the likelihood that a person has an IQ that's greater than or equal to roughly 130.81, that they're in the top 2%. Another way we could write that, if they're in the top 2%, that IQ denotes the 98th percentile. 98% of the IQs would be below that, 2% would be above. All right, one more. Letter K. Between what two IQs do we find the central 75% of people? All right, the central 75%. The central 68% are going to fall within one standard deviation. How about the central 75%? So I'll draw this on here and then we'll let StatCrunch do this. I don't know what these IQs are, but the central 75% of IQs are going to be between one IQ over here and another IQ over there. I don't know what they are. I've got to try to figure that out. You might be tempted to try to do the between. Between doesn't work here, so we can't use between. I did try. If 0.75 is the area in the middle, that leaves 25% that are in both of these tails, and if you cut 25% in half, we're going to have 12.5% of the IQs that are down here, and the other 12.5% of IQs are up here. And again, we're still looking for those two IQs. We're going to do this twice. I'm going to find this one first. If I want to try to find this IQ right here, I could say, hey, the area below that IQ is 0.125. I'm going to put 0.125 in this area box. And I'm looking for when x is less than that value. Wow, how did I do that? That's pretty cool. So it turns out that that IQ is about 82.74. I still can't believe I did that. So that's one of the answers to our problem. Not both of them here, but I'll mark that one down. We got one of them was 82.74. That corresponds to this one. When we come up and find the other IQ up here, there's a couple of ways you could do this. We could leave this area as 0.12. And now we want to know the likelihood that we get an IQ that's greater than some value. You could also still leave this as less than, and we want to find the IQ where we're less than some number here, some IQ, when the area to the left of that point is these two areas combined. Now, that's a little more work, so I'm going to stick with the tail area here and say find the IQ that's greater than, oops, and it just changes that for me. When this area in the top tail is 0.125. Oh, not quite as good on the second one there, but pretty close. And so that IQ is right here, is 117.25. And so the central 75% of people have IQ scores between 82.74 and 117.25. Between those two values is the middle 75% of IQ scores, the central 75%. So when you're doing problems with the normal model, watch the wording. If it says find the probability, and you know the IQ scores or the X values, you're putting them there and your answers will be here. In this video, we knew the probabilities, the areas under the normal model. We put them here and we were looking for observation values. We were looking for IQ scores. So that's it for this lesson.